The big data and data science revolution is upon us as firms are currently spending an estimated $36 billion on storage and infrastructure, and that will double the data mining sector by 2020. Here with us in the TINL studio to talk about predictive analytics is Richard Boire. He's Senior Vice President of Innovation at Environics Analytics. And Richard, welcome to the program.
Thank you, Abe. Thank you very much.
Well, thanks for being here. Of course, we have an expert in our studio in this space. I want to get your take and your definition of what predictive analytics is.
The definition of predictive analytics that I always like to use is the utilization of information in a particular period of time to predict an outcome or event in a subsequent period of time.
Now, again, I want to get your take on artificial intelligence and what that relationship is or how it ties to predictive analytics.
Artificial intelligence is a methodology or you could almost call it another mathematical algorithm that can be used in the data scientist's arsenal to help in the whole predictive analytics process.
Now, Richard, would you say that AI is the next iteration of predictive analytics or not? And is the new taxonomy of predictive analytics to be called AI?
Let me answer the first question. The first question, absolutely, AI, artificial intelligence, is going to be embraced by data scientists or predictive analytics practitioners. We're seeing evidence in some of our existing models where we've started to use AI, and we're starting to see significant lift in performance. And the reason that we're seeing these kinds of improvements in performance is how the technology has evolved. The technology of AI has evolved from what we call single layer. I know I'm sounding a little technical, but they've gone from a single layer perceptron to multiple layers. So without getting too much into the technology, this breakthrough in going from single layer to multiple layer has really improved the performance of AI quite significantly. And certainly we're seeing that with some of our existing models.
Now, you've been researching and following this area for quite some time. How have you seen predictive analytics change over time? And I know you just mentioned some of that change just now, but maybe more in the application of the technology.
That's a very good question, Abe. Where we're seeing the real evolution is more of what I would call the Henry Ford kind of adoption of predictive analytics, i.e., a lot more automation and operationalization of models. So back 20 years ago, where where analysts or data scientists were building custom models, it would take sometimes 4 to 6 weeks to develop a model. There was a lot of handing off of information back and forth, where it took again weeks to sometimes implement solutions. Now we're seeing both the development and deployment of these solutions within the same day. And we're seeing, in some cases, we can see the development of 10, 20, hundreds of models at the same time. And there are vendors and applications out there that offer that kind of capability. So tools, it's really the tools that have enabled practitioners to really take predictive analytics up to the next level, because we now can do things quicker. And we can actually look and see where, even by doing things quicker, are we actually indeed even getting better solutions, because we can try a lot more different things in a much quicker way. Whereas back 10, 15 years ago, it would have taken us another few days or another week to try some new algorithm.
So, of course, predictive analytics can be used for many applications. What's a common use of predictive analytics that we can really point to today?
Well, the early adopters of predictive analytics were direct marketers, what I would call CRM, the customer relationship marketing type of people, where we were building models to help target customers that were most likely to respond to a particular offer. So who's most likely, if I'm a credit card company, who is most likely to respond to my credit card offer to become a credit card member, or who is most likely to become a new customer of my organization. Which products am I most likely to buy? On the other side is the area of risk. So which customers are highest risk in terms of be on the credit card side in terms of credit card risk? Are they most likely not to pay? On the insurance side, are they most likely to have a claim? And how do I price? Given that I know what is the likelihood of that claim and the expected loss cost of that claim, how do I price that? So these tools have certainly within in the area of insurance have been embraced in a very, very big way, because organizations can now price policies in a much, much more effective way than they used to, let's say 10, 20, even 50 years ago. The area of actuarial science was always implemented or developed with trying to help in the area of pricing for premiums, but predictive analytics and data science has helped to take that discipline up to the next level, where we're actually building better pricing models to help organizations manage their whole pricing schemes.
Richard, do you think that predictive analytics could in fact have a negative effect on society and really the way that we can be monitored at any time, maybe more so with our personal trends, our personal habits?
Yes, definitive yes. I think the area of good governance and the area of privacy needs to be front and center in terms of making sure that people understand how their information is being used. I certainly don't want to develop models or solutions against people that are not willing to give their information up willingly. So again, I think we want to be open and transparent in how the information is being used. I've always been a believer that we're using this information to target and to hopefully offer the right products to the right people at the right time. And so I've always been a believer that predictive analytics is helping us do things more efficiently and more effectively. But having said that, I think we need to be very open about what this information is doing or trying to do. And I think there's a gap in terms of what the general public thinks versus those of us that are actually working with this on a day-to-day level. And the governments are trying to intercede to try and manage that, but at the same time, the governments don't have a lot of knowledge in this area as well. So there's a lot of growing pains amongst all the stakeholders in terms of how we're going to manage these governance and privacy issues going forward.
Richard, are there new ways that we can expect machine type data or data mining to play a role in our lives that we may have not heard about yet?
In the areas of AI is probably where the biggest developments are going on. The area of image recognition. This is where artificial intelligence has made great strides. I remember reading literature 20 years ago where they were using again AI techniques to try and predict images, and it was not very good to make the point. But as I said, the recent developments in the last 5 to 10 years in AI have now produced dramatically, significantly improved results in the whole area of image recognition. And so you're going to see a lot of these techniques being used. Like, can we use images to help us in predicting whether, for instance, whether a certain how much we should how much a certain claim is going to cost. So if I can go in and I can get I can get an image or predict what this image looks like, can I then go in and predict what the cost of that certainly the insurance industry, what the cost of that claim might be.
Now, Richard, IoT really matters to TIA members, particularly in the industrial sector. How would you say predictive analytics will impact the industrial IoT space?
Well, in the area of IoT, I think this is again where you're going to see tremendous power and results, more so than in the areas I typically operate in. Because in the IoT area, you're talking about defects or processes, and how can we go about improving processes? How can we go about predicting defects? If we have a particular manufacturing process, can we go in and determine whether a defect is likely to occur? In this area of IoT, one of the things I haven't mentioned is this whole area of noise. The signal-to-noise ratio, which is the key element in terms of how well artificial intelligence is going to perform, is the key factor. And when the signal-to-noise ratio, in other words, how much of this data can we truly explain? If that is quite large relative to the random noise, these techniques, AI works quite well. And in the area of IoT, the signal-to-noise ratio is quite large. So these techniques work quite well in this, in a machine-to-machine type of environment. So with regards to sensors, these techniques and the use of AI is going to predominate. My area, where I'm dealing a lot with consumer behavior, both on the risk side and on the marketing response side, the signal-to-noise ratio is quite low. So we end up looking at a variety of techniques which look at both AI as well as some of the traditional techniques to see where we're going to get the best results. But certainly in the IoT area, great strides are going to be made because the use of AI is going to be, I would almost say, exclusively used within that type of environment.
Well, TIA members develop and really innovate the infrastructures to allow AI and predictive analytics technologies to function. So it's good to see that being applied, and it's good to have somebody like you to let us know what we can expect going forward. So thanks for your time.
Thank you very much, Abe. Thanks again.
Richard.